Hey everybody, tonight I have an interesting generalization of an SMO problem, and I believe we need R to be greater than 0. You'll see why as this unfolds. And again, this is a generalization of an SMO problem. Back in 2021, it was problem 15, I think. And in that problem 15, I think it was R equals to 8, okay? So, but I noticed that when you work this out, this was the pattern. It was R and then 3/2 R, because this part right here, I believe, was 12. Okay, so let's see how this goes. Now, one thing to notice right off is that both sine 2x and tangent x are going to be greater than 0 in this interval 0 to pi over 2. Again, that just comes directly from the unit circle definitions. They're both strictly greater than 0 in the interval 0 to pi over 2. Okay, now let's move along and see how this goes. It goes fairly nicely. As you might anticipate, you use the double angle formula here. Sine of 2x is 2 sine x cosine x, a very well-known result from trigonometry. All right, and so that's all that happens going from here, or going from this piece to this piece right here. Okay, now another thing that turns out to be very useful is it's something that's, it happens a lot in trig, where you use this identity. I guess it's the Pythagorean identity. But R is equal to R times sine squared x plus cosine squared x, because that identity is always equal to 1 for all real x. Okay, so, and again, that's going to come into play, you'll see already probably. Again, folks, this guy right here, sine squared x plus cosine squared x, is identically equal to 1 for all x, all real x. And so that's what we do on this very next line. Notice that we had 3r sine squared x. Now down here we have 4r sine squared x, because you had an extra copy of sine squared. From this, you would have r sine squared x, which would add to this 3r sine squared x to give 4r sine squared x. Okay, and of course the r cosine squared x comes from right here. So that's what happened going from this step to this step. Okay, now there's something called the AM-GM inequality that comes in quite handy, and let me write it down. I think I left myself enough room right here. If you have two positive real values, a and b, their arithmetic mean, a plus b over 2, is always greater than or equal to their geometric mean, which is the square root of ab. Now, a way to kind of keep this straight, if you haven't seen, this is super popular in competitions. But what's really going on here? You see the 2 right here. It's a divisor. Right here, you have a 2 index of the radical. It's often left out for the square root. The square root is such a common symbol. But you see, this 2 and this 2 are kind of duals, if you will. This is an addition 2, and this is a multiplication 2, if you want to think of it that way. And this generalizes a plus b over 3 is greater than or equal to the cube root of abc, and so on. So that's what we're using exactly from this statement. Okay, this isn't an application of the AM-GM inequality, where a is r cosine squared x and b is 4r sine squared x. Okay, and so the rest of this is fairly straightforward. You get this truth right here. And then when you divide through by 2 sine cosine x, that's going to cancel out just to leave this 2r that you see right here. Okay? So that's pretty interesting the way that works out. And so the minimum value on this interval, the minimum value, let me just come up right here, is just 2r. Okay, for any positive real number, if it's 0, I don't know what, it's not much, I guess it's not very interesting, it's just equal to 0, right? So it may be true. But anyway, it definitely true for positive real numbers. So this is our answer. This is the minimum value. Okay, and again in the problem 15 2021 SMO, if r is equal to 8, let's see, that would mean that the minimum value was 2 times 8. The min would have been equal to 2 times 8 equals 16. If you take the time to graph this, you'll see it repeats. I think the period may be pi. Okay, but if you draw a picture of this, you'll see, whoops, that's equal to 16 right there. Erase. It's equal to 16. All right, and again, that was just the constant they kind of, I guess, arbitrarily chose. But it works for irrational numbers and rational numbers. So anyway, this is the solution. And again, you can make up any problem you want. I don't know if they've made up other problems like this in the SMO Senior section. But anyway, that is it. Let me know what you thought about it. Good night.